Now here's our sample space for 3 coins, something you should be familiar with by now. We're going to define an event. An event is just something that can happen when you flip 3 coins, okay? The event in this case is going to be at least 1 head and 1 tail. Okay, so 3 coins, at least 1 head and 1 tail. So an example would be, say, tails, heads, tails. There's 2 tails, well that's at least 1, there's 1 head, that's at least 1. Okay, so what I would ask you to do is write down the sample space and circle the outcomes that would correspond to this event. And you should do that, hopefully you've done that. Okay, well this one wouldn't, because all 3 of these are heads. This one would, because you have a head and a tail. So we've got a head and a tail here. We've got a head and a tail here. We got a tail and a head here. Tail and a head here. Tail and a head at the end here. Not this one. Okay, so we see that 6 of the 8 possible outcomes correspond to the event. We conclude that the probability of the event is 6 over 8, which of course reduces down to 3/4. 75%. 75% of these outcomes correspond to the event of at least 1 head and 1 tail. Now that was easy enough. We counted 6 outcomes that correspond to the desired event. There's an even easier way. Now again, that was easy enough. There's no need to get lazy and try a much easier way, and more complicated problems often there is. For example, an alternative way to count the event is to count the outcomes that don't correspond to the event. Now, what doesn't correspond to the event of at least 1 head and 1 tail? Well, that's going to be all the heads are the same, all heads or all tails. Okay, you don't have any mixed. So heads would correspond to, would not correspond to this event. Tails would not correspond to this event. Okay, so we get 2 outcomes don't correspond. So 8 minus 2 equals 6 outcomes do. And that, again, leads us to the same conclusion about the probability of the event. When you have only 8 events, it's easy enough to count the ones, or 8 possible outcomes, it's easy enough to count the ones that correspond to an event. If you have, let's say, 4,096 elements in your sample space, 4,096 possible outcomes, and only 2 of them don't correspond, it's a lot easier to count the ones that don't than the ones that do. And that's a lesson we want to take on as we move forward in the course. Okay, now the analysis we're doing here, we're doing 2 things. We're counting the event. We're counting the things that happen to correspond to an event. That's what we do in Chapter 11. In Chapter 12, we then put that together with the total number of events in the sample space to get the probability. But the probability in a case like this, in these examples, is easy enough to understand. So we're going to go ahead and talk about the probability right now, but then we're going to just concentrate in the chapter on the counting. We might mention probabilities, but we'll get into the probabilities more formally in Chapter 12. It's important, I think, for you to understand why we're learning to count things, so that we can put the counting together into the whole idea of probability.